In this video, we're going to talk about percent yield. I've done a problem already right up here. Is carbon monoxide plus 2 moles of hydrogen gas produces methanol. We were originally given 356 grams of the carbon monoxide and 65 grams of the hydrogen. Doing our stoichiometry, I determined that the amount produced of methanol was 407 grams. That meant that the CO was the limiting reactant and the H2 was in excess. I had some left over of that. And I had figured out how much we used in reality of the hydrogen and how much was in excess. Often you'll go through all of this, okay? And you can watch other videos to see how to find limiting reactant and how to find excess. And then there's one last question. It will say the student goes into the lab and they get X amount of their product. What's the percent yield? So here's your formula for percent yield. Percent yield is the actual yield. Sometimes I will use the word experimental. That seems to help students. This is what you get in the lab. So we physically go into the lab and we do an experiment. So this is the amount that we get in the lab divided by the theoretical yield. The theoretical yield is what you get from the math, from the stoichiometry. This is perfect, angels are singing, there were no mistakes, the exact amount that you would get in the lab if everything was perfect. So let's put a note right here. This is called your theoretical yield. It's what you get from the stoichiometry. It's what you get from the stoichiometry. That's the exact amount, okay, that we should get. So in this example, let's say that you and I go into the lab. We do this experiment. That would be pretty fun to produce some methanol. And let's say that we get 398 grams of the methanol. And we want to know, well, what's the percent yield for that? You simply take what you get in the lab, the 398 grams, and divide it by what you got from your math, from the stoichiometry. Well, the exact perfect amount, the maximum that could be produced, would be 407 grams. Then you just multiply that by 100 to get it to a percent. So let's do this. We're going to have 398 divided by 407 times 100, and that is going to give us a 97, wow, we're really good, you guys, a 97.8% yield. It tells you how close you were to that perfect theoretical amount. Now, I want to tie this into percent error. All you have to do is subtract that from 100, and that would tell you the error you had in the lab, how far off you were, how far away you were from that true theoretical amount. So the percent error on this, if you subtract that from 100, would be 2.2%. We only had a 2.2% error. So there is a relationship. Percent yield is how close you are to that true amount, that theoretical, what we would get mathematically, the perfect amount. And then the percent error is, well, how far away were we? How wrong were we? Where was the amount of mistake that we made? And that will always equal 100%. There is theoretical compared to your experimental to give you a percent yield. Good work.